Okay, let's start. Okay, first exercise needs a lot of drawing, so maybe it's better if I like show you his solution and explain how he did. Okay, let's see how much drawing he. Okay, do you see? If I do it with a mouse, it will take a long time, so maybe it's better to show you what he did. Is that okay?
Yeah.
Sure. Okay. First, this photo doesn't have anything to do with this exercise. It's for the second and third one. So this photo, no. This photo is, I don't know. For, where can I find it? Oh, here's for drawing. Let's take a green one. Okay, this photo, no. Okay, let's now go. Maybe. Or doesn't matter. Okay, doesn't matter. Let's go here. You need this information and you need to write them in a table here. Start by writing only one of these halves, because then you need to copy paste another because it's same. For example, AAB is same as BA. So you write this AB6, AC4, blah, 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 and all of them. Do you understand how he wrote them? I'm thinking yes. It's pretty much intuitive. Okay. He can ask you two things: to find a path from A to, I don't know, here, starting from A. So from A to A. And he can ask you, you can ask him on an exam, do you want the shortest path or you just want the path? He here did both things. If you're searching for the shortest path, you're searching for the smallest number that you jumped, but you didn't jump before. For example, here I have AB, which is 6, AC, which is 4, AD, which is 6, AE, which is 6, and AF, which is 5. And what's the smallest number? It's 4. So you jump from the C. Here you're looking what is the shortest, and here the smallest number, you find 2. So you jump on a B. You see AC, AB. And then on the B you're looking for the smallest number. See that we have 2 here, but he didn't jump here because that number is already here. I already jumped on C, so I don't want to return like A, C, B, C. It doesn't have any sense. So he doesn't want to return to C, so he's searching for the next smallest number. For example, if here was 4, or I don't know, 3, he could jump on. If he's 3, he could jump all here and here. It doesn't matter if there is 2 same numbers. But because we have 2 here, he jumped on E. So he's now here. What number we have on B? We were already. On D we were not, so he jumped here. He could also jump on F. It would be okay, because we didn't visit F yet. So here, but I don't know, he chose this. Then on the end, so it's on D. We have 6, 3, 3. Oh, we have E, but we were already on E, so nothing about that. And only thing that is left is F. So here 5. And now, right now we must jump on A because we need to return to vertex A. So it's just this. And here's written. Do you understand what he did?
Can you explain the whole thing from the beginning? I actually don't understand shit. What are we trying to achieve?
We want to find the path. Okay, here is the written thing, drawn thing. You don't need to draw it, but here's drawn thing. And we want to find a path from A to back to A, but to visit each cell once. See, B, C, D, E, F. And each moving has some weight. For example, from A to B is 6. We want to find a path which has a least weight, if I can explain like that. You understand what's the problem?
How do I find the one that has the least weight? Like, do I have to make the table for it?
Yeah, you need to make a table and always jump on the smallest one. on the number that has on the like relation that has least weight. For example, you see from A to F it's 5, from A to E is 6, from A to D is, I don't know, also 6. I'm not sure if the picture has a lot of numbers. From A to C is 4, and from A to B is 6. And what is the best solution from A to C because it's the smallest number?
So we don't have to draw this complete
No,
graph.
you don't need to draw it. You can draw it, but you don't need. If he
I
doesn't,
think it's way easier with a table.
yeah, it's way easier with table because you have so much information. Okay, if there is only 4 dots, maybe then it would be easier. But right now you have A, B, C, D, E, F. You have 6 dots. And a lot of relationship. Look how many are there? A lot of them. It's basically every dot with every dot. Okay, does anyone understand and would like to try?
Me, maybe.
Have a different exercise, maybe.
Well, let's try with the same one. Let's try with the same one because I don't have the other exercise. Maybe in other review there would be. Let me see. Because I think some exercises from tablet review and review are different. But we here doesn't have anything except tablet review. So no. Wait, maybe. Nope. I'm not sure. Okay. Maybe if I like move. So you don't see what he did. Okay. Where would you like to jump?
I could try.
Yeah. You are here on A8, on vertex A. Where would you like to jump?
Ček, šta želiš da ti govorim? Što da pišem u tablicu ili samo ovaj drugi dio?
Ne šta da pišeš u tablicu, nego drugi deo.
Dobro onda. So, I mean, the lowest number is 4, C.
Oh.
So I would like to jump there first.
Okay, you're on C. Now?
Now I can choose D or F or B. No, I have to go B. Sorry.
Yeah. Okay, what's the next one?
Now I'm on B, so I can go to. I can't go to C, so I have to go to E because I've already used C.
Yeah. Okay.
Now I can go to D or F, and let's say I'll go to D.
Okay.
I'll go alphabetically. And now I have used E. You used
A, B, C, D.
I can use only F.
Yeah, you're right. And from F, the only way is to A
because we used all other letters already.
Yeah. And now you just put numbers. Okay, from A to C is 4. From B to E is 2. Oh no, first then you need to from B to C. From C to B. From C to B is 2. Okay, how much is from B to E?
2.
From B to E.
2.
Ah, okay. From E to D.
To D 6.
From E to D.
Aha, Bože, 2.
Okay, from D to F.
Now it's 5.
Okay, and now from F to A.
Also 5.
Yeah. And it's 20. 4 plus 6 is 10, and 10 is 20. And that's solution. If we see what Amber did, we did pretty much the same thing. We also got 20, and that's the solution. Does everybody understand the first exercise?
Yeah.
Yes.
Okay. Let's go to another. Okay, for this and this, you will 100% got one of these, or maybe even both. So this exercise you should know because it's easy and it's not that hard. So let's use joint. Paint. I think my mouse skills will get better.
Better than Ambrose, for sure.
Okay, first you need to draw a graph like this. Let me copy paste this graph. Copy to clipboard. The best resolution ever you ever saw. Let me
What
just,
program is that, by the way?
what?
What program do you use for the screenshot?
Green screen. I think if you're using Ubuntu, you will need to press Shift something, but if you're using Windows, you can just press print screen and he will let you like do this. Wait, not this. And he also save as, save directory, open in image editor, copy to clipboard, you can choose it. If you don't click anything, if you just click close that, it will automatically, I think, copy to clipboard. Yeah. Are you sure? On my computer, nothing is happening. Maybe I deleted it. I don't know why.
Peasants, you don't have touch screen.
No. This is my laptop for the.
Keyboard is
I'm
Windows.
just joking.
Yeah. Just a second. Just a second. Okay. Okay. If we have depth first search and breadth first search. Before doing his example, let me show you what's the difference by writing it in a little bit easier way. Or maybe it's better first to write dots. A, or maybe 1, 2, 3, 4, 5. Okay, let's just go with the most basic one. Let's start with DFS. D stands for depth. And for what does that mean? You're going from the first dot or the dot that it said. So here is vertex C, but let's in this example start from dot 1. I will use other color. And choose one path and go to the end. For example, 1, 2, 4. Then you return to the closest dot that has something to do next. For example, 2, 5, and on the end, you return to 1 and 1, 3. Do you understand the idea behind depth first search?
Отприлика.
Okay. Let me. Breadth first search is searching by level. So what does that mean? What does that mean? It's search He searched 1 2 1 3, then 2 4 2 5. So he didn't do 1 2 4 2 5 1 3. He did 1 2 1 3 2 4 2 5. Do you understand? Can I hear some answer? Please. Others?
My internet mezeza.
Not really.
Al kužim.
Okay. Then let's try on his example. Let's try on his example. Maybe I'm wrong, but I think he on our test give us like this, like three on the same side or like on different way, but similar like this. And what is the x is from C to G. So I need to find from C to what fuck to G. A, B, C, D. Oh, okay. On G like a graph. It's not to G dot. Okay. So how does it? What is doing? I think Ambrose first make to one table, but let me remember a second. Just a second. First, he write said all, like I don't know why, but he's writing what is from what dot is possible to jump where. So let's make a table. Let me see. Yeah, okay, don't look at his example. Okay, I can look at you on other screen so you don't see the solution. Okay. Let's start with the first table. You write all the dots. So let's write them. A, B, C, D, E, F.
What happened to the pen?
My battery, A, B, C, D. Oh, E column. Now I'm using mouse. Just imagine this scale with mouse. I think I'm not that bad. Because I can read my writing, so I hope you can. Okay, from A, where you can go?
To B and J.
Yeah, you're right. Okay, from to B and G. Okay, you're right. From B, where you can go? Where you can go from B? Anyone?
L, and I don't see the other letter. An A.
There's like you say. Oh, do you see this?
Prespojio sam se sad na bolje internet. Ovaj.
I see.
Optimizacija.
The letters are blurry.
Okay, I'm not sure how because all his pictures.
Zoom in, yeah.
Okay, K. A, K, L.
From
J.
B, from B, where he can jump on from B.
HKL.
Yeah. From C.
LMD.
Just imagine there is S, L, S, D. Okay, from D
MC.
and M. Okay, from J.
A, B.
Yes. from K,
BO.
yeah, from L,
BC and K.
and from M
CD.
in the same time. Okay. I don't know why he write these tables, but he write because he wants to see this. Don't ask me. Where's my mouse? Oh, here. Okay. Now the next table is the table where you write like the path where is he jumping. First you write which method are you using. Here is this time we're using depth first search. And the next one is and then like this. Stack is where I can jump. And vertex is where I jumped. So because it said that we start from C, you are on C and you're jumping on C. You're not jumping anywhere. Where I can jump from C, you're writing it here. Where do you jump? You can choose. Where I can jump from C.
I don't really get it. I get it when you. I did get it when you draw it like the simplest way, but.
Okay. From here. Yeah, DLMN. And choose to jump on one of these. You can choose any. DLRM. Choose one. Which one would you like to jump?
M.
Okay, let's jump on M. Okay, right now I'm on M. What is the possible dots where I can jump?
CD.
Yeah, you're perfectly correct. Where I can jump from okay, I need to add. Where do I need to add? I'm not sure. Okay, where I can jump from M.
Where can you jump from M?
Yeah, from M. Where I will jump from M? No, where are you going to jump from M?
D.
Yeah. Here we forgot one thing. What we forgot? We forgot L because you can also jump from C to L because we were here before.
So it doesn't have to be direct.
I think they don't need it, but sometimes I'm not sure. In his examples, he's writing L, sometimes he's not. I don't know what to tell you.
Probably the longest route.
For me, it would not be logical to write L, but I don't know. In some examples, I look, he's writing, in some examples, he's not. So I would stay with one thing and continue.
Are we finding the longest route or the shortest route?
How we will search, for example, just imagine that you have a maze. And you can go this and this way. I don't know, something like here, blah, 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 blah. And you need to search the whole maze. And there, like the thing what I wrote in this start.
So basically, we're trying to go to all the vertices.
Yeah, we need to search the whole thing. And there is two kind of searching. One is go like this, or no, you're going for the longest part. This, and then you do this, not this, this, and then you go this.
And we can go back to points that we have already been on, right?
Yeah. In let me use a color, it will be much more understandable. For example, this, and then he immediately is here. He doesn't need to go back from here to here, from here to here, from here to here. No. From here to here, and from here to here. I think you would need this like logic when you're doing exercise in programming. It would be like to find some path. I'm not sure which path, but I think there was one problem with that. It was a name romb, like I think like the thing with cleaning.
Do you mean relative path?
What?
Are you talking about relative path?
Yeah, right. Do you have something to ask?
I just don't get the point of the exercise. Like I don't get what the question is asking.
Maybe you want to read it? The second one.
So that just means that I have to find a path that doesn't overlap one of the vertices.
Yeah, but you need to use DFS algorithm.
So yeah, we have to know those two algorithms and
Do you know? Okay, the first question. Do you know why there is algorithms for this? Anyone?
No.
Okay. Right now we have a small maze, and you can do it in pretty much, I don't know, maybe a few minutes. But just imagine that this maze is much bigger, and you would not be sure that you passed everything. And what's the worst thing is that if you would like to do it, it would be take you a long time. So if you make like algorithm that we can explain to computer and we can leave him do it, it would be much easier. Do you understand?
yeah, it's more like the best way to do it.
Yeah. Not maybe the best, but the way that computer can do it without thinking.
Yeah.
And go through everything. Because maybe you would say, oh, let me find the shortest path from A to M. You will look at the picture and you will say immediately A, B, L, C, M. Yeah, because you're human, but computer would not say. Computer would try this. He would try everything, and he will say, "Oh, this is the shortest." But if human would do every time that, he would take much more time. Or just imagine if the maze is much bigger. If there is, I don't know, 81 dot, for example.
Yeah, of course.
Is this Python? No, I don't want that. No, peut-être qu'il dira. Oh, no, I give him the big number. Okay, here. See, I'm searching the path from like the horse jumps, like that kind of dots are connected. This and it doesn't matter. And if you try doing it by your hand, it would be much take a lot of time. And because I like put him like the way that he needs to search, he can do it alone. Same thing we are using here. We don't want to. No, Spotify. So this and this. We want to find like something that we can use every time and put someone others doing without using head. And two algorithms, DFS and BreadFS. One, search like the longest path that you can go, search or not the longest, search one path to the end. And then here is search from this vertex every possible path and then go to next. I will draw it again. Okay, let's use it. Maybe.
We can like just redraw the graph that he gave us in that way, you're drawing it now. Like it will make it more simple for us.
I'm
I
not
feel-
I'm not sure because it would not look this good. This is just much simpler because I'm drawing a simple graph. But if you try to draw his graph, it would look something like this.
we can imagine it like turned the other way.
You can imagine. Like here is, for example, A. Okay, let's A, J, B, K, L, and he only want to C and D, M. This is how would his graph look like this. And breadth first search with a B, we would search like this. You see? Like this. By levels. Like what I can search from A. I can search J and D. From J I can search D, but why would I search D when I already have D? So search K and L. Is this L? I'm not sure what I wrote here. L. Then from K I can search L, but why I would search L? Because I already search L. So let's search from L. Only possible thing what I can search from L is C. And then from C there is D and M. That is breadth first search. How would DFS work? Does anyone remember?
So first we have to go to JLB or B.
Yeah. Yeah, where would you like to go?
Let's go B.
Okay, let's go to B. Okay. Next.
Let's go to не видим кое слово. L.
Yeah, I wrote it better. So which way? Do you want to go KL like this? Or you want to go with
BL.
A? Okay, just like okay. Next.
So we have to go to C.
Yeah.
And let's continue to M.
Okay, and what's the next one?
J. No.
D.
D. Toda.
And then you're going back until you find the first path that can go to another dot that you didn't go yet. For example, LK. And on the end you have BG, and that's one, for example, solution of that first search. Do you understand?
Yeah. Depth first search is all about going deeper.
Yeah.
And the breadth first search is about like searching for one directory first and then going into another subdirectory.
Okay, just one point for breadth first search, because Ambrose like it because it's like a common rule, but it's not a rule. Ambrose likes to go always from left to right. What does that mean? To go from this, like first left, if I can go left, go left. So if I can choose to go from left or right, go left. And everybody is doing like that. I'm pretty much sure, because you don't want to search everything and go to the last one. Just go with the first one, because first one is possible. Because it's taking time. For example, if you have, for example, one dot and A, B, C, like look at all of them and go with last. What's the difference if I can go with this one? You understand?
Yeah.
It's not a problem, because you can just like mirror this, and then left would be other thing. But if you're writing it, just try with the left one. Ambrose would not take you points, but it's just like practice.
So it's better to go. It's better to go A, J, B,
yeah.
K.
Yeah. This weird thing. L.
But in breadth first search, we have to go like first. We have to go to JB, then to
No.
L,
You're yeah, JB. Yeah. Then
KL
yeah. Then
or LK, right?
yeah, it doesn't
Yeah.
matter. It doesn't matter. Okay.
And
next
then
one.
C and
Yeah.
DM.
Yeah. There's a lot.
Okay.
Yeah.
Okay. Then the only thing left is like writing it. So what you're writing here? You're writing where you are. So it starts from where you are. I'm on C because it said that I'm on C. Then I'm saying where I can jump. From C, I can jump or D, M, and L. I write it. I don't know, like LDM, DLM, LMD. You can write how much, how would you like? I think it would be best practice to write LMD, but it doesn't matter. That's like one possibility where I can jump. And we choose to jump on M. We could jump on D, we could jump on L. You can choose wherever you would like. We jumped on M. I'm not sure who said. Let's jump on another dot. Okay. Okay. Let's try some other path. Where would you like to jump? If I'm on a C, where would you like to jump?
L.
Okay. Then where I can jump from L?
C. K. I don't see the other letter. B.
C. B. K. Okay. Then where are we going to jump from this?
Okay.
Just don't write C because you're already on C. So don't jump. I don't know why I forgot. Just don't write C because you were already on C. Like you started from here. Is that okay?
Okay.
Mm-hmm.
Like why I would go, I can always go CM, 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 CM. It doesn't make any sense. So from L, you're say Vicky, where would you like to jump from? On B or K?
Okay.
Okay, from K, where you can jump?
B only.
Okay, I jump on B. Then from B, where I jump? J or A. Okay, where I can jump from A. Yeah, and what is left? What is left? Yeah, C can jump from to back. Oh, maybe that's the why Ambrose always write every possibility. He would always write DM, 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 because I mean he would pass you even like this. Okay, then you will jump. So from J.
Oh, can we go to both M or D now?
Yeah. We can go to both MD, but I'm thinking maybe it's better when he write to write every possibility where you can jump. For example, because I didn't jump from D and M, you can write also here D and M. You understand? I can still jump to here to D and M. You understand why? I'm not sure. I'm telling you, Ambrose is sometimes writing it, sometimes not. Look.
Well, I don't really get it. Shouldn't we go deeper if it's?
I'm just telling you because look, here is also a photo. For example, he can jump from M to D to L. He roll across the C, so you're not writing in C, and that's all. And then when he's on L, he's writing L and M. But he was
Okay, so
already on
that's
but he was already on M. But why then he is not writing when he was on K? Why didn't he write L?
so that's where we can go from that point.
Yeah,
But,
yeah.
It's not where we should go.
Yeah, but I'm telling you, sometimes he's writing yes, sometimes he's not. I don't understand his logic. For example, look at L. From L, you can jump to C and K. But he's writing also. Oh no, from L you can he wrote B and K. Okay. Then from B he wrote B. I don't know why he wrote 2 times B. Doesn't I'm telling you, sometimes he's writing something that doesn't have any logic. And then from B he said AJKL. Okay, if you say AJKL, why then you didn't say from L to C? Okay, maybe because we started from L to C. But then why didn't you wrote from K to L?
Yeah, I was actually paying attention when he was explaining it, and I was really confused because it makes no sense. Yeah, I thought that I don't get it or something. So yeah, it's way better when you write it like your way, I would say.
I got maximum points on these exercises when I wrote it, and I wrote it where I can jump, not where I can go back, because I saw sometimes he's writing where he can, for example, why he wrote here 2 times A. Nobody knows. I would just say nobody knows. Or why here he wrote 2C and then crossed both of them. I would write where it's possible to jump from here. You understand?
Yes.
That's how would I do. Because in his example, I don't know what to tell you. So say okay, let's write BFS. And
maybe he writes it because he wants us to like see it and ask him about it or something. I don't know, but yeah, it's very confusing.
I think we are on C again. I should write here stacks and vertex, but it would take a lot of time because I'm writing with a mouse. Okay, we are using, let's use green. Let's use it. Where I can jump from C. If I'm using breadth first search. So not this one, the other one.
DLM.
Where?
D or L or M.
Yeah. Why is not writing number? Same thing as you did here. It's not that it's not that much different. I would just say nice. Okay, then let's start. I don't know. Let's finish first the smaller one. So D and M.
Let's go to D. Yeah.
Yeah. Okay. It's left M and L. So right M is small. Right M. Okay. No. My bad.
We have to go to M, right? Not L.
Yeah, from C to D. But I'm thinking how to write. Yeah. Okay. But I need to write all here. Oh, I wrote L. Okay. My bad. I thought this is C and I confused myself. I don't know why I thought this is C. It's not C itself. So DLM to the ML to DLM to D. Okay, I wrote it. Then from D, I'm going to M, but I'm not going from. I'm going to from C to M. How to write in this notation? Just a second to remember. This is like first in, first out. But, let me see how he wrote it. 1, 2, 3. So he wrote DLM, then BK, okay, which has logic, and then AG. Okay. Do you know why he wrote DLM and not DML? What do you think? Guys? Because he didn't want to confuse you that he go from D to M. He wanted for you to think that he go from C to M. You understand? But you can write CDCM by writing
Yeah,
this.
he was talking about this quiz and this like getting into bus analogies.
Yeah. You. What's funny is that you will have that on exam on second year first test. This and this. Last in, first out, and first in, first out. Last in, first out is queues, like in Java, and the first in, first out is stacks. So you will have this even in programming. And maybe even in the second year, I'm not sure. We have something else, but it's possible for you to have. I think you will have hash maps, but let's return to math. Okay, so what are you writing here? You're writing where you can jump, like we started from C. Let's not look. From C, I can jump to D, I can jump to M, and let's write L. L, and where I will jump to. What nothing is more possible. Where I can jump from L to B and K.
Sorry. Može jedno pitanje, da se ne razmišljamo o engleskom. Znači, zašto si napisao da i M i L? Znači, što nijako je ovaj depth first search da bi se moralo ići na M, da ne možemo ići na L? Jer kao otišli smo na D i onda je dublje M.
U depth first searchu izražio bi C, D, C, M, N, C, L. Ovdje mogu da skočim samo sa M na L jer sam već bio na D i već sam bio na C sam već bio, sa C sam počeo. Svadaš?
A me ne kužim, ali...
Ok. Gdje možeš da skočiš sa C?
Mogu skočiti na D, M ili L.
Tako, i šta sam napisao D, M, L?
Da, dobro, to kužim.
Ok, što je pitanje?
I sad dalje, dakle sa D.
A zašto na D? Pa već smo bili na D.
Pa ne kao, ovaj sljedeći korak, M i L.
Ovo?
Da.
Zato što sa D mogu da skočim na M i sa C mogu da skočim na L.
Da. Ali što nije da kao moram ići na M, zato što je to dublje.
A sad radimo breadth first search.
A, Isuse Bože. Ne, pa kužiš, ja cijelo vrijeme mislim da je depth first search, da je to zadatak bio, kužiš. Ne, sad mi je puno jasnije. Ajme, grozno, sorry.
Okay, sorry guys, he wanted to ask in mother language. Okay, we're back. Okay, so where I wrote D, M, L, from C I can jump to D, I can jump to M, and last thing is to L. Now from L I can jump to B and K. I wrote B and K. Let's jump to, I don't know, K, and then on left thing is B, jump to B. This B looks like, I don't know what.
Like Ambrose's pigeon.
Yeah, pigeonhole. Okay, and then from B I can jump to A and J. And let's jump to A, and on the end jump to J, and that's all. So that, do you understand or no? Or yes?
Yeah.
Here it's pretty much the same thing. KB, we wrote BK. I don't know why he wrote Jack. Jack. But okay. Okay, the next exercise, if I remember, is pretty easy. Find the degree. Okay, let's not look at his solution. Is this one? Is this one? Yeah. Find the degree of each vertex and verify theorem 8.1. It's pretty much a stupid thing. You just wrote. Where's the picture? You wrote how much, like, I don't know how you could call it, relationships are in tables, and you wrote from each dot. Okay, let's try it. Okay, nice. Okay, how many? Okay, let's go with dots. Write the dots. Is it possible? Yeah. And make something bigger. Let's go with degree 8. Then paste my depth. Let's write all of them. C, A, B, C, D, J, K, L, and then maybe I can make this. Nope. I cannot go. Possible like to. No. No. Okay. It's good. I will just zoom it. You write how many like relationships A have. So A has a relationship to J. Maybe I can zoom it. To J and to B. So it's 2 relationships. Let's use some color. Maybe on the blue one. Okay. How many relationships B have? Anyone?
3.
How many?
3.
No, 4.
Oh yeah, 4.
How many C have?
3.
Yeah, 3. How many D have?
2.
What unloyal dots? Not even anyone in single relationship. J,
2.
K,
2.
2.
L,
3.
and M.
2.
Okay, and let's see who is the macho man. B is macho man. Okay, you like say 2 plus 4, 6. Okay, and this is 10, 13, 18, 20. This is 20. I think so. And then you test this is, let's zoom it, this verify theorem 8.1. On that exam he will write you the real theorem, but you immediately when you write theorem, you know it's the theorem, and you're writing something like this. And this weird thing, maybe I should use black. It looks like a E. I'm not sure how would you like to write. Degree, like same thing as up. Now you write big V, which means vertex, Yeah, that. And you wrote formula 2 times n e. I'm not sure why it's not written r like relationship, but it's written. Oh, it's written e as edges, as edges. Okay, I'm correct. And then because you counted this, you know it's 20. 2 times n, and n is number of edges, which is 10. And how I know it's 10, because I'm sure we wrote this correctly, but if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 20 is equal to 20. You understand?
Yes.
Write E in parentheses.
Edges. Ivica na našem, edges. Like,
Any for number of edges.
Okay, I get it.
let me show you. This is Rubik's Cube. And I'm not sure if you ever tried to solve it, but this is edge.
Okay.
Yeah. Across the top, and then you get the corners, and then you get the edges in the middle. Across the
How much time do you need to solve it?
Sorry?
How much time do you need to solve it?
45 seconds.
Oh, you're really slow.
Really? No way, you're cheating us right now. No way.
I need less than 20 seconds.
What?
Yeah, because you know the what's it called? The algorithm.
I know F12 very good, and I know full PLL and a lot of OLL.
I only know TLO right now. I was trying to learn, but I stopped.
I stopped like 1 year ago, but it's like with you. I don't know how to explain it. It's like a learning bicycle. On competition, my lowest time was 70 seconds. 17.
We're gonna have a Rubik's Cube show off next time we have a tutoring hours. I can feel it.
You have a speed cube?
Yeah, it's GAN 356 SM.
Nice.
Yeah, it's really good. I thought about changing it, but I like this one because I pretty much did a lot of things to her. So it seemed like that it's used.
Any lube?
What?
Any lube?
No.
No lube?
No lube. Yeah, it's funny. It's funny that I'm not using lube, but I'm not using lube. Because come on, then it means that I need to like take care of her, and I'm not that competitive.
Well, I knew how to solve the small one.
I'm back, comrade.
2 by 2.
Have you ever tried to solve like bigger one, like 7 by 7?
Do 5 by.
No, because Mo was like, "There's math tutoring right now," and I was like,
Oh my god, the math. I'm gonna kill myself.
Please don't kill yourself, please.
I got a scholarship.
"Huh?
I got a scholarship.
I didn't. I'm wasting money."
What?
No, it's still like less than I would have paid back home, though. You know, because
Then again, the pressure is on because I have to keep I have to keep the scholarship now. Whatever. Anyways.
Okay, do you want to continue? Or yeah, maybe it's something interesting. Okay, what's the next? Count the number V of vertices, the number E of edges, and number R of regions of the map. Okay, very familiar formula. Okay, but it's pretty much. But I need to do this for some dot. I cannot say like for. My bad. Okay. What you need to do, like count the number of vertices. Count. Okay, let's first write his formula. Okay. What is V? V is number of vertices. N of the. Okay, do I need to write, or you can just, I don't know, remember or write for your own? Guys,
Sorry? What did you say?
I asked, do I need to write what is V, or you can just remember or write for your own? Because writing like this will take a lot of time.
Well, like, yeah, sure. You can.
This is V is number of vertices,
And R?
number of dots, like A, B, C, D, M, T, A, K, L, M. So it's 8. Like numbers of vertices, I don't know how we would like to call dots, points. Is that okay?
Yeah, sure.
Okay. E, number of edges. So these relationships, like number of relationships, AJ is 1, AB 2, JB 3, 4, 5, 6, 7, 8, 9, 10. And R is like the most confusing one, but it's like number of regions. What does that mean? There is harder way of finding it, and there is easier way of finding it. I will show you both, and then you can choose. Harder is like to find a region, and this is like 1. This is second one. This is third one, and this is fourth one. And you can ask me why, I can explain you. And there is much easier way, and that's to find the longest path in this. For example, not the longest, but like the shortest longest path. Okay, let me show you an example. From A to M, A, B, L, C, M. It has 4 of them. 1, 2, 3, 4. Do you see why I choose from A to M or A to D? Like choose the 2 dots that's like the most away, like there's like, I don't know, the furthest one from another, and then find the shortest path to it. Why? If someone asks why is this doing, and what is the logic behind this? Let me clear. Main page, yeah. For example,
Mogli smo uzeti i tipa J i ovaj.
Yeah, A and M, for example. Yeah, I do again the same. 1, 2, 3, 4. Would be more logical to write it 3 here, 4 here, 5 here, 6 here, and 7 here. If someone asks you, well, how many regions this have, you can say 3. 1, 2, 3. It's much easier writing like this. But in this scale, what it's much easier to do, find the longest path. For example, 1, 2, 3, and this is again 3. I'm doing the same thing here. Do you understand how I got number 4 in this example? Yes or no? Anyone?
I'm thinking, but so longest path in this example is 4, right?
Yeah, find the longest path, but when you're finding a path, please don't go, for example, if you want to go to B, don't go A, J, B. Go in like the shortest, like the smartest way. Like the longest path, but the smartest way. Don't be stupid and go
longest distance, like longest distance, the smartest way, the shortest way.
Yeah. Don't go like A, B, L, K, B, K, L. Don't like make 3 circles here and continue. Do you understand?
Yeah, of course. Yeah.
And then you just write number of vertices is 8, number of edges is, I think, 10, if I remember correctly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And plus regions, which I think it's 4. Did I? Yeah. For example, from okay, please anyone choose some dot. But look for the first dot. Don't choose B, because then you can go only to this close. Then choose AJ or DM. Like choose one on the end.
D.
For example, from D. Let's go from D to A or J, because that's like the longest path. D, C, L, B, A, which is 1, 2, 3, 4. You understand how I got 4?
Yes.
Nice.
So the longest path is supposed to have like the vertices don't double again, or
Yeah, don't double it. So okay, if for example, if you go from D to A, don't go D, C, L, K, B. Like don't make the longer path. You don't need, because you have shortest right here. If you don't have it here, then it will make one more. Okay, let me show you.
hold on, but he said he wants the longest path, so like okay, it's the longest path not
Just imagine that this here doesn't exist. Okay. Then it will make more regions. This will be 1, 2, 3, 4, and 5. But let me show you the smartest way. For example, from D to A, then it will take you 1, 2, 3, 4, 5. Do you see?
Yeah.
Because this is not more region. It took 2 regions to get. Okay.
Okay.
Does everybody understand?
Yes.
Okay, then let's continue. Let's continue. How much is this? Is 2 magical, and 2 is 2. Done. Nice. B1. And that's all. Look, you wrote this on the start. Vita 2, I forgot to write 2. And every time you can make any of this, it will be equal to 2. And if it's equal to 2, you proved I don't know how it's called. Euler's formula.
Is it always 2?
Yeah, it's always 2.
I got one question.
Okay.
When they ask for the longest path, should I care about the weight or no?
Yeah, weight is making the longest path. Oh, in this example or in which example?
Any example, like if there's a route, like let's say there's like a route that takes 4 edges and there's a route that takes 5 edges, but the 4 edges has more weight than the 5. So do I take the 4 or the 5?
Okay, first, I think he will never ask you for the longest path. He will ask you for the shortest path. But I think if you're trying to find the longest path, then you will count the weight, and you will see if 2 of these is making more weight than 1 of these. You understand? So if you have one that is 1 million and you have 2 of them that is like 3, it's better to go with a 3. So if you want the longer path, you will take 1 million. You understand?
Okay, thanks.
But he will, if he asks you something like that, you can ask him like, do you want by weight or do you want by like distance? And I'm sure he will say by weight, because I remember I asked him, I think, a similar question. Okay, let's see what's the last exercise. Consider the graph G in FG. Okay, this exercise is the exercise that doesn't have any theory. It's like we being the stupid. Consider graph G. Okay, again, the graph G, and find the all trails from A to C. There is no math. You need to do it on your own. Okay, let's try to find the, I know, the stupid one. A, B, L, C. I can make from I can also go to J. So let's write A, J, B, L, C. I can change also L. So it would be A, B, K, L, C. And I can change both of them. A, J, B, K, L, C. And that's all. This example, if I'm correct, I think it will gonna give you because he knows that everybody can do it and he wants to give you 3 points. You understand? Does someone wants to try?
I mean, I would like to try. Can you починайте питання сам?
So find all paths from one vertex to other vertex.
Ага,
This example is A to C.
да. I can try it if anyone
Okay.
else maybe wants to.
Okay, try from M to B. Okay.
Okay, so one possibility is MC, L, B.
Okay, nice. What's the other one?
Okay, now MC, LKB.
Okay.
Okay, now I MDC.
Oh, this M looks like I'm not sure what. M, what you say? M?
DC,
Okay.
LB,
Okay, and what's the last one?
MDC, LKB.
D C L K B. Okay, that's it. That's all. That's all. I think it's pretty intuitive exercise. Am I right?
Yeah, it's easy.
And the last question is distance from J to M. And that means like the shortest path from J to M. You just write it down. It's like a question, what's the distance from, I don't know, Dubrovnik to Zagreb? You will not say, oh, go to China and then from China go to America and then from America go to Zagreb. You will find the shortest path. Okay? So let's see. From J to M. From J to M, J, B, B, L, L, C, C, M. Okay? And you just, you write it a little bit like, see, like distance, and then you write which dots, JM, gem, linolade, something, marmelade. Okay, and no, again the D. Again the D. Okay, and then you write JB. Then from B to L, C, M. How many these things have? 1, 2, 3,
And now,
4. Okay, we have only this left. This and this. And for matrices, because you're online, you don't need to worry because you can use online solver. I said it a lot of times. But please don't do it or not. I don't know that you use it. I'm not saying anything. Okay. Yeah. I showed you so you can practice.
Yeah, for practice, we need to
Yeah,
go.
so you can do it, practice. Yeah, that's the thing. Okay, so you have this. This is pretty easy. Matrices, and okay, I can do it. And the graph theories, which a lot of them won't come. I think I'm not sure even if one from this one is going to come. Like this one is pretty much easy. You just see if there is, you can write this as 2 times something, which means I would say param broj.
Even number.
Yeah, you try to, if this is even, it's graphical. If it's not, it's not. Come on, it's pretty much easy. Like 3 plus 3 plus 2 plus 2 plus 1, it's 13. It's not even, it's not graphical. 5 plus 4 plus 4 plus 3 plus 3 plus 3. It's how much? It's 22, which you can write 2 times 11. It's graphical, da, 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 da. And this also like top. How much is it's 14? You can write 2 times something. It's graphical. It's pretty much easy. What is this? I would like to see the exercise. File all different trees of 6 vertices. It's like how much, like draw. You will see him. All the possible way, like to draw a 6 vertices. And I'm not sure. Oh, it's here. Don't ask me what is he doing here. I don't have any idea what is he doing here. I don't know which is this exercise. Write of the following collections. I don't know what the text of this exercise is. If I know the text exercise, maybe I could help you, but I need to look. I don't know. Wallace 7-3. Okay, but don't worry about this. Like all the way, you can write 6 vertices, and that's like this. It's pretty easy, and here he's going to do this pretty much same thing, but with 4, if I remember correctly. It's 1, 2, 3, 4, 5. Wait, is he drawing the same example more times? Find all different ways to draw the tree as 3 diagram. Oh, let me see. Okay. Okay. He's just trying to find a different way of drawing it. Okay, it's not that hard. This one. Oh, this I think he even gave you a funny example in the class. Did you give some example with the bridges?
Well, I remember him mentioning bridges and some guy on some island or something.
Yeah. And if I remember correctly, he gave you impossible exercise. Just a second.
I don't really remember it like now.
Don't worry. It was a funny exercise, and that's all. I think even he saw it in some magazine. But what is it? Hamilton close, but okay, and you just put in formula if I'm correct. Yeah. Okay, this is not that hard. If this example come in exam, I think he will give you the pretty much same example as this, like this one. It's not going to change anything, because I think he gave us like the same one, totally the same one. Is this even an example? 6. Okay, this is not that hard. Easy. Maybe we can do this one because he didn't do it. Okay, do you want to do it right now, or you want to stop, or anything?
Can we stop?
Yeah.
It's getting a little bit late, and we have other stuff to do too.
Okay, because I also want to go on pancakes.